Hello and welcome to this screencast on the vector equation of a straight line. Now what I'm going to start off with, I'm going to draw a particle here and I'm going to call this particle Q. So the location of this particle can be defined by a point vector, or position vector, sorry, Q. Now Q will be travelling along a vector or in the direction of a vector which I'm going to call V. And at some point in the future, Q is going to end up over here, and I'm going to call this position R. Okay, so the particle starts at Q, and if it moves along the direction of V, and it's going to eventually end up at this position given by R. Now this is the explanation of a vector equation of a straight line. And so if I can calculate the position of R in terms of Q and V. So if we start, R will be equal to the position vector Q plus our vector V, which is the direction it will be going in, and I'm going to multiply V by a parameter, and I'll call that parameter T. Okay, so R is the R is the position that our particle ends up in, Q is the original position, V is the vector in the direction it will be travelling, and T is some parameter. Now this is the vector equation of a straight line. Okay. Now it helps to think of T as being in terms of time. Okay, so if you think about it, we start with Q, and if we think of V as being a velocity vector, okay, so V is velocity, Q is our start position. At some point in the future, we're going to end up at R. So let's have a look at an example of this. So let's say I have a particle, and I'm going to start my particle at position 1, 2, 3. This is just made up, as you probably guess. Velocity vector, again I'm making up these values, and let's say what's going to happen when t is equal to 1. So if this velocity vector is in terms of meters per second, what's going to happen after 1 second? Where is q going to end up? Okay, so if we use our vector equation of a straight line, okay, so we have the position q, which is 1, 2 and 3, plus the velocity vector 1, minus 2 and 3. That's multiplied by time, which is going to be 1. So it's going to be quite an easy calculation, this one. So if we just add these two vectors, 1, 2, 3, add 1, minus 2 and 3. Okay, so 1 add 1 is 2, 2 minus 2 is 0, and 3 add 3 is 6. Okay, so the position of our particle R after 1 second is going to be at 2, 0 and 6. Okay, what's it going to be after 5 seconds? Right, so let's scroll up a bit. So what happens when t equals 5? Okay, so if we use the same vector equation, so we have q, which is the start point, plus the velocity vector v, and this time we're going to multiply that by 5. So I'm going to have to do a scalar multiplication first. So the q vector remains the same. I'm going to have to multiply the velocity vector by 5. So we're going to have 5 minus 10 and 15. Okay, so that's 5 times 1, 5 times minus 2, and 5 times 3. Okay, so if we add these two vectors together, we have 6 minus 8 and 18. Okay, so after 5 seconds, our particle is at this position. And finally, what happens after, say, 10 seconds? I'll just scroll up a bit. Okay, so all we do is replace t by 10, and we do the same thing again. So the q vector remains the same, plus the velocity vector, and this time we multiply the velocity vector by 10. Okay, so it's q plus v times t. So we have 10 minus 20 and 30. So if we add these two vectors together, we have 11 minus 18 and 33. So as you can see, it's quite simple. The application for the vector equation of a straight line is quite simple, and hopefully, well, we're happy that we can use the vector equation of a straight line.